Okay, I'm going to start working on the AQA physics papers, GCSE, O-level, starting with the June 2015 AQA GCSE foundation tier for June 2015, code number PH1FP for foundation paper, and it's the June 2015. It's an hour long. For this paper you must have a ruler, a calculator, the physics equations sheet which is enclosed. So here is the first question. Different parts of the electromagnetic spectrum are useful for different methods of communication. So what I've done is gone into presentation mode for Evernote, and so here's the question in a more in a clearer way. Okay, so different parts of the electromagnetic spectrum are useful for different methods of communication. Figure 1 shows a transmitter, so that's figure 1, and it's showing that transmitter emitting two electromagnetic waves, J and K. So there's J and there's K. Okay, put that phone on silent. So it's showing the ionosphere, and the ionosphere is a part of the atmosphere which reflects electromagnetic waves, so that people on one side of the earth can transmit signals which can be received on the other side of the earth. Okay, so wave J is reflected by a layer in the atmosphere called the ionosphere. So there is J. J has been reflected. Okay, but one thing to note is that we've got a line here and it's dotted. That line is called the normal. Okay, it is normal to the tangent of this point for the ionosphere. So the normal would be like that, and then you get the normal. Okay, the normal is like that, and that's the tangent. Right, so what is the question? Wave K will also be reflected by the ionosphere. On figure 1, draw the path of wave K to show that it does not reach the receiver. Okay, so K would not reach the receiver, and we have to demonstrate how. So first of all, I'm going to copy this figure. In fact, I've already copied it. Okay, but if I was to do it now on a Mac, you'd press second function command 4, and then you select what you want to copy. Okay, so that's been copied to my desktop, and then I will go onto here, Sketchbook Pro, and I've already opened a page in Sketchbook Pro, so I'm going to import that image. Go to my browser, go to desktop, look for the latest one, open it, and there it is. So let's put it like maybe there. Okay, so the question was to show that wave K does not reach the receiver. Okay, so there is wave K. It's not going to reach the receiver, and so to show that, what we need to do is select this tool. First of all, I want to draw the line which is going to help me draw the normal. So this line would have helped to draw this normal. Okay, but let me change the color. I want to extrapolate K to see how far it would have gone. So it would have gone this way, like this, straight. Since it's a wave, it would have been gone straight all the way up to the ionosphere. So I would stop it there. Like that. Okay. Then I would also draw what might look like the tangent at that point, and that's the tangent. Okay, then I would draw the normal to that tangent, so it'll be somewhere here. So that is the normal. Okay, it should be a dotted line, but anyway, we're gonna leave it like that. And then I would come back here, and this is what I want to do. I want, because this is the angle, install update, remind me later. Okay, remind me later. Right, so this angle, okay, between J and the normal, okay, should be equal to this angle for reflection to take place. So the same thing is going to happen here. We're going to have another line here, okay, whose angle is going to be the same as this angle. Right, so we need to get the line drawn from here and make sure that the angle is about the same as the other one. And as you can see, it's going to totally miss the receiver. Okay, so that's the angle. So these two angles are equal. Okay, so by doing this, I've demonstrated that wave K is going to be reflected here, but it's not going to pass through the receiver. Okay, so that's the first part. The second part, what is the name given to the line in figure 1? The dashed line. So the dashed line, like we said, is called the normal, and this is how you spell normal. So it's called the normal. So this here is the normal. Okay, the dashed line is called the normal. Then that's one mark. 1b, figure 2 shows a transmitter sending a signal to a satellite orbiting the Earth. Okay, which type? Okay, so this time we've got the ionosphere. There is a transmitter, it's going through the ionosphere all the way to the satellite. Then the satellite would transmit to the other side of the world. Now, which type of electromagnetic wave is used to send a signal to a satellite? Okay, draw a ring around the correct answer. Okay, satellites use microwave radiation. Okay, satellites use microwave radiation, so I would say the answer to that one is microwave radiation. Okay, microwave radiation. Okay, and then the next part, what is the name given to the process that occurs as wave L passes into the ionosphere? Now, when it's passing through the ionosphere, it's different from when it's being reflected. So here it's being reflected, but here is being refracted. So the answer to that is refraction. Okay, so it undergoes refraction. Now, what is diffraction? Diffraction is what happens to a wave when it passes through a small opening whose dimensions are comparable to the wavelength of the incident wave which is going through the opening. But in this case, this here is called refraction. Okay. 1C. Waves J, K, and L are electromagnetic waves. What are two properties of all electromagnetic waves? Okay, so we need to tick just two. All electromagnetic waves are longitudinal. No. The reverse is true. All electromagnetic waves are transverse. So I'll put a tick on this second one. All electromagnetic waves are mechanical. That is not true. All electromagnetic waves have the same speed in a vacuum. That is correct. And all electromagnetic waves have the same frequency. That is not correct. So the two answers are the second one and the second from the last. Okay, so all electromagnetic waves are transverse and they have the same speed in a vacuum. So that's 1C. Okay, so that's it for number 1 of the AQA Science A Unit 1 P1 Physics P1. It's an hour long. We've just done the first question. It's a 2015 June exam. Okay, so I'll see you when I look at number 2.